It's all good, Jake.
Hey everyone, thanks for hopping on. We're just gonna give it a couple minutes before we get started here. While for those on, we're just gonna give it another 60 seconds before we kick things off today. Okay, we're gonna go ahead and get started while others are still joining. Thank you all for hopping on with us this afternoon for a webinar with the Energy Management Association. My name is Sam and I'll be your moderator today. I'm going to go over a few housekeeping notes before we enter into business today. Presenters will be answering any questions until the end of the presentation, but we do encourage you to submit them at any time using that Q&A button at the bottom of your screen. If you happen to be experiencing technical issues, please use the chat function to inform the panelists and we will assist you. This presentation is being recorded and will be available for viewing within 1 week for on-demand credit. And then finally, again, in terms of continuing education credit today, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. However, if you're a certified CXA or EMP, please expect the CEUs from today's session to be automatically uploaded to your respective portals. So today's webinar is Installation Pays Off, the business case for energy appraisals and inspections. And today is a special webinar because last year the Energy Management Association signed a memorandum of understanding with the National Installation Association, who Dave Cox is the immediate past president of, to facilitate collaboration, education, training, and information sharing. So this webinar is just a continuation of our newfound relationship. And David's going to share a bit more about NIA as we go along. A little bit about his co-presenter, Jake. He's a senior project manager at Tight Fit Covers based out of Indiana. He has over 15 years of commercial and industrial mechanical installation field experience. Last 6 years honing his skills with custom, removable, and reusable installation covers. And David today is the National Installations, as I said, immediate past president. He was the first manufacturer member to serve as NIA president. He works in strategic business development in North America, technical installation at Owens Corning, which is headquartered in Toledo, Ohio. And since beginning his career there in the 80s, Dave has held multiple leadership roles and is a vocal advocate for the benefits of installation that brings to all sectors of the economy. So, without further ado, I'm going to hand it off to our experts here, starting off with David. Take it away.
Well, thanks, Sam. Hey, I want to make sure I got Sam and Sim correct here because I've never dealt with an organization where we had two ladies here. One's named Sim and one's named Sam, and I'm not very good with vowels. So we've had a heck of a time trying to coordinate between the two of us about what's going on here. But I wanted to thank the Energy Management Association for having us on today, and we'll get started. So first of all, who is National Installation Association? We are a not-for-profit organization based out of Virginia. We've been around since 1953. And we are the voice of the mechanical insulation industry to keep you as the viewers and our members up to date with the latest industry trends and technologies. We have over 280 member companies throughout North America and really around the world. And it really comprises around manufacturers, distributors, contractors, and distributors. Take a look at those pictures down at the bottom there. People might sometimes wonder, well, what's the difference between mechanical insulation or industrial insulation and maybe residential insulation? Down on the bottom left, you'll see a picture of piping system there that might have water going through it or some kind of processed fluid. That has no insulation on it, but right next to it, you'll see a refinery there or a chemical plant that has insulation that's covered up in what they call cladding, a metal cladding or GRP cladding. And on the right-hand side, you'll see a picture of the same kind of insulation, but with different kind of cladding on it, which they call a PVC. So it's kind of hard to describe by just talking about it. So we thought we'd show you some pictures as so people can see exactly what the differences are between mechanical insulation and maybe residential insulation that you may have in your house. Today, we want to talk about just a couple different things. One of the things that's offered from National Insulation Association is an inspector program. It's a 2-part 4-day class that really teaches people how to inspect a system that's in place right now and to make sure it's compliant with mechanical insulation specifications. You do get PDH credits for that. You can see on the slide here where the next classes are. And it's a great class for anybody to attend. And it's really a way for National Insulation Association to really help our industry really be the best it can be. Next slide is really what we're here today to talk about, specifically around Jake with Fit Tight Covers, around some of the work that they've done in terms of an energy appraisal. We offer a class through NIA to teach people how to do what Jake's going to talk about today. And it's really the heart of what we're talking about today is to do an appraisal on your insulation system. And so this is a 2-day course. We'll actually go through and learn how to use a computer program called 3E. And it actually will help you figure out your insulation thickness, your corresponding energy savings, your dollar amount, and also, of course, greenhouse gases as well. It's a great class. I've been through it myself. A lot of people in our industry have. And the training documents and all the people that are already certified as part of the IEAP class is down there on the bottom right-hand side of your slide. So we have a really great story to talk about in terms of mechanical insulation. If you look on the left-hand side of the slide, you're going to see all kinds of great benefits that come from mechanical insulation. If you look at the picture in the middle there, where it shows the piping, what that is you see those of you on the call that are from Pennsylvania, you know all about fracking and moving natural gas across your state. There's compressor stations out there that make a lot of noise, and they have to reduce the noise. So if you look at that middle picture, that really talks around noise reduction as one of the benefits on the left-hand side. You go to the bottom picture there, we have that thermal image of a valve that's not insulated. Well, that's obviously going to play into personnel and equipment safety and process control and some greenhouse gas reduction, no question about that. On the right-hand side, you'll see a picture of a stained, if you want to call it that, a floor where there's dripping water coming off a piping system. For those of you that are in classroom situation that's in the audience, or you're in a commercial building, sometimes you see a stained ceiling tile like you see in the bottom right-hand side. Again, that could be a leaking roof, but in all probability, it's probably got something to do with condensation coming off your piping systems. So there's all kinds of different ways by which mechanical insulation is a nice benefit for the users. We always have to do a shout out here because we often say we're not a sexy business or a sexy industry. We're kind of quiet and we're unassuming. So this is our attempt to glamorize our industry a little bit. For those of you old enough to remember, from 1980, John Travolta did play an insulator in the movie Urban Comedy. So I'd highly recommend that you go to your web browser, if you're using Ask Jeeves or whatever you're using, go on there and take a look at it, and you'll enjoy the movie, and you'll certainly enjoy that song by Johnny Lee, which is Looking for Love. Just a great movie, and again, it's kind of neat to the fact that John Travolta was playing an insulator in that movie. So how do we get started in all this stuff? I want to back up for just a minute and just explain to the audience here about where all this is coming from in terms of greenhouse gas reductions and things. It really started out in this Paris Agreement. Actually, before that, in Kyoto and Copenhagen, there were several United Nations treaties that got started talking about this kind of thing around global greenhouse gas emissions. So really, it started back in Paris in December 2015 and entered back in 2016. But really the goal, why we're doing all this stuff, why you read about windmills, why you read about electric vehicles, why you read about all this other stuff that's going on, it's really to limit global warming. And the world and the United Nations does have a goal to try to keep that under 2.7 degrees or 1.5 degrees Celsius. So what happened was back in February 2021, when President Biden came into office, the first thing he did was sign an order to get us back into the Paris Agreement. And that happened back in early 2021. And that's basically when the thoroughbreds lined up at the starting gate and were getting ready to leave because of the fact that we rejoined the Paris Agreement back then. And then all of a sudden, all this stuff started happening within the United States. And then what happened in April of 2021 in Glasgow, Scotland, the United States submitted a new, more aggressive, what they call an NDC, a national determined contribution under the Paris Agreement, to really, it's literally almost doubled our greenhouse gas target to a 50 to 52% reduction below the 2005 levels in 2030. So as you read throughout your papers and magazines, however you get your news, you're going to start to see a lot of things being targeted towards 2030. That's when a lot of the countries, a lot of the states, a lot of the cities all have some kind of aggressive goals to reduce some kind of CO2 goal or greenhouse gas goal by 2030. You may know that in August, the Inflation Reduction Act came into play just this past August. That's got $369 billion worth of energy security and climate change information, benefits to society here in the United States. And again, the aim is to reduce carbon emissions by 40%. There's a bunch of different information in that. We're hoping that in the future, we could have another webinar to talk about this stuff specifically in terms of how mechanical inflation can actually play into sections like Section 303, 50161. There's a bunch of different information in that bill that I think would benefit our industry. When you look at CO2 management, this is important for you to remember as part of today's talk, is that there really are two types of carbon known for sustainability reasons. When you look at sustainability definitions, there's a thing called embodied carbon, another one called operational carbon. We're going to spend a lot of time today talking about embodied carbon, and that's the carbon footprint of a material cradle to grave documented by an EPD, which I'll talk about in just a minute on a specific manufacturer. We also have operational carbon. That's the stuff we might all be familiar with as we're sitting here listening to this presentation today. You probably have an HVAC system pushing out either heat or air conditioning, and that's the building's energy consumption. That's where mechanical insulation comes into play. From the CO2 emissions reduction technology, again, I'm talking about technology here. I'm not talking about going out and planting a tree or something like that. We're talking about technology. You either do one of two things. You basically reduce it at the source, or you reduce it, it's already in the atmosphere that's already been let out. What I'm here to tell you is that mechanical insulation and everything that you see here on the slide, it's in green where there's some kind of action item. Mechanical insulation actually plays a part in that. If you look at the technology around direct air capture there, very expensive technology, kind of promising technology, but again, in terms of reducing CO2, it's pretty expensive per metric ton of getting that taken out. We'll talk about that in just a second. I thought the audience might find the picture on the right-hand side there, that 1 ton of CO2 equals a balloon 33 diameter. So if you just think about that, every time you think about you're driving your car or driving your truck or something like that, 1 ton of CO2 is a balloon 33 feet in diameter. When you talk about greenhouse gas tracking, again, my point in showing you these kinds of slides is to illustrate to the audience that this is serious, that this is not a passing fad throughout our country or throughout the world, that greenhouse gas is somehow going to be going away or some kind of fad. It's not. In fact, the SEC is involved in terms of public companies around Sustainability Accounting Standards Board to hold companies accountable for how they talk about greenhouse gas tracking. There's companies that say, we're going to track scope 1, scope 2, or scope 3. You can see on this slide, which you'll be able to get a copy of later, what kind of emissions contribute to each one of these, scopes 1, scope 2, or scope 3. I thought I'd particularly call out scope 3 there, where you see business travel. So I remember getting a plane ticket and it says on the plane ticket how much CO2 my flight from, let's say, Charlotte to Texas is going to be. And I thought, well, that's kind of interesting. Well, the reason that's on there is that eventually that's going to be tracked in some way by some government agency or through a public company, because that's what's required for scope 3, that's going to be tracked, just like employee commuting. So again, this is a very conscientious effort by a lot of different organizations to track greenhouse gases, because it's a very serious issue for the planet. Another example of some of the ways by which buildings are being called into play, which is great for us as mechanical insulation, is because an example is New York City. Back in 2019, they enacted a law called Law 97. And again, their goal is to reduce emissions by 40% by 2030. You're going to continue to see as we go through the presentation around talking about meeting certain goals by 2030. But look at this. It says that beginning in 2024, buildings over 25,000 square feet will have to meet certain carbon emission limits based on the facility's group type. So if you're a daycare center, a healthcare center, you're going to have different goals to have to meet. And that's eventually going to happen really starting and beginning in May of 2025, because the reporting is going to have to be done by a registered professional. So again, what you see going on around us is really going to impact mechanical insulation. And what we're here to tell you is our industry is well prepared to help people meet their CO2 goals in a quite effective way. So let's talk about the ways that we can offset CO2. One of the things that comes into play is that the very top of the slide, it says it is an obvious choice. It doesn't say it is the obvious choice. It says it is a choice. And by looking at this slide, I think it becomes clear in terms of how we can illustrate the ways by which you can offset the CO2 emissions, particularly, let's just say, of a full-size pickup truck that's driven 20,000 miles. If you drive that truck 20,000 miles, this happens to be my truck, because I've got the label off the truck, and it says that my truck will put out 18,000 pounds of CO2 if I drive it 20,000 miles. And so basically what that does is tells you that's 9 tons of CO2. So Jake will when Jake comes on, he'll talk about a website that EPA puts out, and it can actually calculate how many trees would be offset my truck, can be planted to offset my truck, how many 43 watt incandescent light bulbs can offset my truck. I think one of the things I want you to pay attention to, you can see it on the left-hand side of the slide, is that one of the things that we can compare to make this illustration come to life is that if you see on the bottom left-hand side, you see a bare 4-inch pipe at 350 degrees, that heat loss of BTUs per hour per foot, that's 1,460. What that's telling you is, and there's a technical guy that I remember from long ago, Doug Fass, that told me, hey, BTU could be best illustrated by a lit match. So you think about a match, that's 1,460 matches of BTU that are being emitted every hour per foot of a piece of pipe that's uninsulated, that's 4 inches at 350 degrees. So that illustrates the amazing amount of heat that comes off of a pipe if it's running at 350 degrees. One of the things that we've really realized as part of the mechanical insulation industry is because we operate at higher temperatures, we have what we call bigger, higher calorie input in treating CO2 emissions, because we operate at higher temperatures. So the higher the temperature that you play, what they call delta T between ambient and the pipe itself, can really play a big impact in terms of CO2 emissions and heat loss. But if you look at that carbon dioxide, how many pounds per foot per year? So if you have an uninsulated pipe, that's basically 2,500 pounds per year. But if you insulate it with just 2 inches of fiberglass, you come up with 2,300. So it's just amazing in terms of savings. So it's really an amazing story. You can actually offset a truck that's driven 20,000 miles, 9 tons of CO2, and all you have to do is insulate 8 feet of bare pipe that's running at 350 degrees with only 2 inches of fiberglass. And so it's really a compelling story. And so this is a way that we as a trade association try to talk about these kinds of things and message the importance of our products. This is an environmental product declaration, snip of a way that we do assessments in terms of life cycle analysis. So the EPD is primarily done and verified by third-party organizations such as UL or SCS. There's others, but what they do is they'll work with a manufacturer and they'll come up with ways to check out embodied carbon. This document is a comprehensive document. I've seen some that are 30 and 40 pages long that document in a great detail as to what kind of emissions that their product puts out in these different stages. So the important thing for you to remember as part of the audience here is that if you look at raw material acquisition, you can call that stage 1, stage 2 as you go from left to right across there. Is that one of the things that we see is this cradle to gate, which is A1 to A3. That's called cradle to gate. That's basically the CO2 that's used to manufacture a product, which is where most of the CO2 comes from when a product's manufactured. In most cases, it comes from the manufacturing of the product itself. We call that cradle to gate. And so every one of these stages right here, you can check what CO2 emissions are for stage 1, stage 2, all the way down to stage 5. And in fact, you can actually look to other chemicals as well in terms of water, acidification, ozone, and things like that for every one of these stages. So it's a very comprehensive document. Here's a manufacturer here. One of the things that I wanted to leave you with today too is a way that people talk in terms of sustainability. When people talk sustainability with a building owner or whatever, they talk about footprint versus handprint. The footprint, as you can see at the top left-hand side, is the impact of a manufacturing process on the environment. The handprint is the benefit of the product to the environment. So if you look on the left-hand side, going back to the truck example, that you can see on cradle to the gate, this manufacturer company A says, you know what? It's going to take about 7 pounds to make that 1 foot of 4x2 pipe insulation. 7 pounds. If you look way down at the bottom, the full EPD says that if you go from A1 to C4, which is what I just showed you in the last slide, from start to finish, which is cradle to grave, it's a little bit over 7 pounds still, about 7.5. So let's just say it's 7 pounds. So it takes you 7 pounds to make 1 foot of 4x2 pipe covering as an impact to the environment. But if you look over on the benefit side, going back to the example that I just showed you previously, that it's going to save you 2,300 pounds. So it's incredible to think the benefit versus the impact that mechanical insulation actually plays out. So one of the things that you can see here is that in one day, you can save as much CO2 as it takes to make the product. So the impact is incredible. One of the things I'm going to leave you with as well in terms of how we made this chart is that as an organization is that it's really around how much we can save in terms of CO2 relative to other products as we move forward. So it's a great story. And one of the things I want to leave you with before I turn it over to Jake, and Jake, I appreciate you hanging with me on this, is that some of the key takeaways is that we want to make sure that we conserve. That's the first thing we ask for as an industry to the people that are using our products or thinking about using insulation is to reduce before produce. We have some sayings within our group that says, you know, the cheapest energy is the energy you don't use in the first place. So in other words, don't use the energy in the first place, insulate it first so you don't have to add another ton of air conditioning or add another boiler or whatever. Look at your system, see if you can insulate it and save that way. We do say that we have high calorie impact at a low cost and it's readily available. And as Jake's going to talk about in just a second, he's going to talk about energy surveys. And so you can download the 3E software. You can actually go into the DOE Industrial Assessment Center. You can go check those out. We have 37 of those located across the United States that'll actually go in and have students that are part of, like a couple that I can go off the top of my head is LSU or Rutgers, where they have kids part of an engineering department, and they'll go out and do an assessment at certain companies. You know, you have to look at the website there and you can see where this can be done. And there's a heavy emphasis now on the Inflation Protection Act. We also have a list of energy appraisers available as part of a National Insulation Association, like Jake. So Jake, this is probably an appropriate time for me to turn it over to you, and you just tell me when to move the slides as Jake talks about some wonderful work that his company has done with a client and put sustainability in action. So Jake, I'll turn it over to you.
Thanks a lot, Dave. I'm Jake Jordan with Fit Tight Covers. I've been in the industry for about 15 years now. Started out in the mechanical installation, in the field, installing insulation. Now I'm over in the removable cover side, and we also specialize in energy appraisals. Specifically insulation energy appraisals. And so I'm going to talk a little bit about that today. But before I get started, got a little, Dave, you can move the slide. So if anyone knows this, who said you miss 100% of the shots you don't take? I think the answer is pretty obvious. If anybody's ever watched The Office, it's a pretty notable scene. Something that I thought was funny, has always stuck with me. But the key here is, all jokes aside, any uninsulated piping that you have is running at 0% efficiency. So just adding 1 inch of insulation typically gets you to about 90% efficiency on steam. So take the shot. So we can move to the next slide. So an insulation appraisal, it's a way for us to quantify how much energy a facility is losing in its current condition, and we can demonstrate how insulation upgrades can reduce energy demands, improve facility process controls. Saving energy will in turn lower your fuel costs, and ultimately we're going to be able to reduce some greenhouse gas emissions, which seems to be more important than the reduction of fuel costs, or it's becoming more important. So a few things that an appraiser would need to have to be able to perform one of these, as Dave mentioned, the Certified Insulation Energy Appraiser Program offered through AIA. And they also, as Dave mentioned, offer the inspector class, which is also a great class to have to help identify what parts of the system are failing or damaged or missing. Lucky for me, I've had plenty of field experience, so I can walk onto a job site and I can quickly determine what the customer's installation needs are. But for someone that doesn't have all that experience, the inspector class would be really great to have. So with a little bit of knowledge about what you're looking for, and the 3E+ program provided by NYMA, you can start to process your own appraisals. And before we move on to the next slide, so an insulation energy appraisal is different than just a blanket energy audit. And so an energy audit is a broader look at the entire energy consumption at any given facility. It's not going to be as in-depth on the insulation specific parts. Usually they hit on HVAC, lighting, windows, wall insulation, the condition of the roof, and there's a lot more to that. There, electrical systems can even play a part. And so we're just specifically talking about the targeted insulation appraisal. So on to the next slide. We were able to do a really in-depth appraisal at a local pharmaceutical company. They had tons of potential savings, tons of potential CO2 savings is what we should have said there. They had a published global initiative to be carbon neutral by 2025, which seems very aggressive. And also, I don't know, without using a lot of carbon offsets, I don't think there's any way to get to the carbon neutral goal by 2025 without insulation being a huge part of that. So what we're looking for at a facility, we get on site, we get with the plant personnel that generally had made the call for us to come out, and we're going to look at existing facility piping systems. And usually what we're looking for is a lot of the missing and damaged insulation is at break points and lines. So spots where they have to take the piping apart to replace a valve or to service a piece of equipment, or add a new line in. A lot of times these changes get made and the re-insulation of the part of the project maybe falls to the cracks, or the insulators stop when they get to the flanged connections and the unions and valves. This is very common in our industry. And I think maybe 20 years ago, these things weren't as high profile items to cover with insulation, because energy savings and greenhouse gas emissions weren't as important then as they have become now. So every facility that I go into, I could identify probably 10% of the facility's insulation systems would be just an easy way to point out, 10% of their system could use some upgrades, and generally it's more than that. And as Dave mentioned, it's not just low-hanging fruit, it's literally just fruit laying on the ground. When I went through my first energy appraiser program class, one of the things that stuck with me from the instructor, and I can't remember who the instructor was, but he said if there were $20 bills dripping off of an uninsulated steam valve, eventually somebody would come by and sweep that up. And that's basically, what's going on when you have uninsulated systems that are just radiating heat into the atmosphere, and then you have to offset the heat loss by generating more heat, which in turn uses more fuel, which in turn costs more money, costs more greenhouse gas emissions. So lucky for us, the local company that we worked with, their mindset was to reduce before they produce. So we were able to go in and help them out quite a bit. Dave, if you want to go to the next slide. This chart shows the reduction in CO2 and nitric oxides. So with the CO2, it shows 4.8 million pounds of CO2 that's per year emitted in its current state. With our appraisal, we were able to show a savings of about 4.5 million pounds of CO2 a year, and get them down to 377,000, almost 378,000 pounds per year versus the 4.8 million. So that's a reduction in about 2,000 metric tons of CO2, which is quite a bit. So we were pretty pleased that we were able to provide that good of a reduction. The same thing with NOx, 9,700 down to 700. So it's about a 9,000 pound reduction in NOx, or 4 metric tons. We can go to the next slide. This kind of just goes over little bit of what I've just talked about. The project that we proposed had a cost to operate at their given fuel rate, which was $2.50 a decatherm, which is very low compared then to now to where we're at, which is closer to $8 a decatherm. Their cost to operate was $101,651 a year. And after the installation upgrade package that we proposed, we were able to get that cost down to almost $7,900 a year. The reduction in heat flow was 28 million BTUs per year, which Dave gave me a fun fact the other day that 1 BTU is equivalent to a lit match, the amount of heat that it puts off. So I can't imagine 28 million matches, but I'm sure that would be quite a bit. And then this just kind of reiterates the reduction in CO2 and NOx emissions at a little over 2,000 metric tons a year and 4 metric tons of NOx. Dave also mentioned the greenhouse gas equivalencies calculator, which is on the next slide. And this is provided by the EPA. I just happened to stumble across it a couple of years ago. And I found it to be a very useful tool just to kind of put things into perspective of well, what's 4.5 million pounds of CO2, what does that kind of look like to someone that doesn't know, which I don't really even know what 4.5 million pounds of CO2, I don't know what perspective to view that through, but this chart really helps. It would be the equivalent of 123,000 incandescent light bulbs switched to LED. And so that just kind of shows you how effective insulation can be versus light bulbs. I'm not even sure the facility had 20,000 light bulbs in it, so that would have insulation is clearly the winner when it comes to benefit per dollar spent. And I know the equivalence calculator I was looking at today, and it's the look of it has changed a little bit, but there's also some other data points that you can enter, not just BTUs saved, but you can also use units of gallons of gasoline or kilowatt hours used. There's some different factors you can use there to try to see what you're looking at comparatively to say acres of U.S. forest preserved or wind turbines. Let me get back to my screen here. Okay, so on the next slide, we have sustainability in action. This is just kind of a sample report of a steam valve. We're looking at the thermal image on the right. That's the bare valve. We captured a photo of it with our FLIR infrared camera, showing a 334 degree Fahrenheit temperature. And this valve is completely bare, so it was running at 0% efficiency. The facility that we were at, they had a rate of $4.97 a decatherm. We proposed 1.5 inch thick insulation on the valve, and it showed that it would save about 6,000 pounds of CO2 every year, which is very significant. The BTU costs if insulated as shown, would be $20 a year, compared to the about $270 a year that it costs to operate uninsulated. So that's a savings of about $250 a year. And we estimate a product or a cover or just insulating the valve approximately $400. So your payback on a valve like that is about 1.5 years. And as long as you keep up with the maintenance on the cover or the insulation or whatever product you use, it's pretty well gravy past that 1.6 years. So some other benefits to upgrading to mechanical insulation, just like we provided at the pharmaceutical plant, we were able to improve their process control to where they didn't see temperature spikes in both directions. They're able to keep a tighter rein on their systems, which I guess helps them operate a lot more efficiently. We help reduce boiler usage, which is less chemical treatment, less maintenance, which means less labor for the maintenance crew, and an overall increased lifespan of the boiler. Insulation also improves working conditions. It creates a more pleasant environment. I know over the years I've been in some pretty unpleasant environments, being the guy that's putting the insulation on. So a lot of times I got to be around the bare pipe when it was still screaming hot. And then by the time I was done in the area. And so the next guy got to enjoy the reduced ambient temperatures. Also noise reduction. I know Dave mentioned the gas field uses a lot of sound attenuation, another term for it. It's become a very common practice, is to put covers over these valves that have high velocity gases running through them to reduce the noise. Also, personnel protection. Our industry standard is to try to keep surface temperature below 140 degrees. We follow by this OSHA standard, the state steam and hot water pipes, all exposed steam and hot water pipes within 7 feet of floor or walking platform within 15 inches measured horizontally from stairways, ramps, or fixed ladders should be covered with insulating material. And that's the standard that we go by, 7 feet and below, and we try to keep below 140 degrees. And to try to figure out how to get below 140 degrees, that's where the 3E software comes in handy. There's a section on 3E that shows with different types of insulation. You input your operating temperature, pipe size, orientation, wind speed, ambient temperature, and insulation thickness, or you can set it to vary the thickness to where it'll give you half-inch increments all the way to 10 inches thick, and it'll show you what the surface temperature would be of that insulated section with that thickness of insulation on it. So say you have a 350-degree valve, you can put all your information into 3E, say 1 inch of insulation, and just guessing, because I've done it a few times, it's probably going to get you down around 115, 120 degree surface temp, give or take, depending on what type of insulation you use. Some key takeaways: mechanical insulation, it's high ROI, high value proposition. A properly cared for system could last upwards of 20 years or longer. It really depends on the environment, but once you get past that return on investment, it's just gravy. It's just money in the bank. So it really is a good investment. Like Dave said, it's not the sexiest way to save on energy and emissions, but it's tried and true. It's been around for hundreds of years, I'm sure, and hasn't really changed a whole lot with respect to. There's really no way around it. There's hot pipes need insulation, and there's really no high-tech cure for there's no kind of paint that'll do what mechanical insulation will do. And everyone seems to think that, I've heard people ask, well, what about that insulation paint or that high temp paint? Thickness comes into play when you're talking about insulation, and there's really just no way around it. A fifth of the world's largest companies have stated goals on carbon neutrality, and it seems to me with everything that's going on with greenhouse gas reductions, it won't be long until all of the companies are either joined in with their goals of carbon neutrality or are mandated to, like Dave was talking about with the New York local laws. So I expect there's going to be a lot of people leaning on the insulation industry to learn more about how to get carbon neutral, how to save energy, and how to provide the reports that are going to be required to qualify for maybe some of this inflation bill money. Just glazing through it, I think I've identified about $16 billion that may be up for. They didn't specifically call out mechanical insulation, but there is a lot of wording of energy efficiency and greenhouse gas reduction, which I think fits perfectly into our the story that we tell. So, and details matter. Mechanical insulation can make a huge difference. It may not look like much, but just like the picture on the right, we have two images here. They were taken on an infrared camera. The lower picture is just the stock photo. It shows an uninsulated pressure reducing valve, and you can see the light in the background is kind of blinding. It's it's pretty bright. You go up to the infrared shot, and it shows the light in the background not quite as prevalent as it looks in the picture below, but the valve you can see I think we measured at 355 degrees. And if you look at the coloring of the light fixture, it's towards the lower end of the spectrum. So just goes to show you how things may not look, they may not look red hot, but with the infrared camera, you can see a lot more as far as the heat loss goes there. And we're also looking at these severe weather events that we've been having more often, like the problems they had in Texas a couple of years ago. We got a lot of calls after that to help out with freeze protection, which doesn't directly relate to energy savings, but definitely impacts energy, because a lot of these plants that need their systems to operate are in the energy industry. So there's a lot that we can do in the mechanical insulation field to keep the green energy initiatives moving in the right direction. And as Dave said before, the cheapest energy is the energy you don't use in the first place. It works, and it makes the world a better place. And I'm a second generation insulator, and my dad, he spent 35 years in the industry, and he wanted me to go off and do something different than be in the installation industry. And you know, as a kid growing up, you think you want to have a job that makes a difference. Well, it turns out that we are in that industry, that we can make a big difference. And it just takes a little bit of educating our customers and providing the data that we need to show that we can make a big impact. And that's all I've got.
Okay. All set, Jake and David?
Yeah.
Enter the Q&A. Perfect. All right. Thank you so much. Let us look. We have more than several questions lined up here, so let me start feeding them to you. First one is, who can we call for a career transition discussion, education, potential pay for installation inspection careers? Is that something NIA does?
Yeah, Jake, do you want to talk just a little bit about the career itself? And then I can go down the path of talking about the actual appraisal time.
Yeah, I would think a good starting point would just to go through the NIA and try to get all those courses that we spoke about under your belt. I know my way into this profession happened kind of organically. Like I said, I started in the field, got into the removable side. We started getting into energy appraisals, and it just kind of took off from there. But I would think with the energy inspector class and the certified energy appraiser, that would be where I would start.
I would tell you, we appreciate the question asking about trying to get into the trade and doing some of these appraisals. Like Jake said, I do believe that this is going to be a big thing in the future as companies try to hit their CO2 goals going forward. The training that NIA does have is available to members and non-members, so you don't have to be a member of NIA to take the training. So you can go online when the deck goes back out, Sam, those email address, I'm sorry, the website addresses are on there. You can refer to that and get all the information you want off of the website.
Perfect. Okay. So Darren is wondering, how did you measure pharmaceuticals, greenhouse gas emissions before and after your project? Did you do any benchmarking? Did you use data from software, or was there a direct method of measurement?
So we do have some test and verify procedures. We're still kind of in the early stages of the verification for this particular project. So on the front end, we rely pretty heavily on 3E plus that's provided through NIMA. It gives us kind of just it's not going to be exact science because there's a lot of factors that go into measuring your current state and then going back and measuring the state of your process equipment, you know, after the fact. If you're talking about an HVAC system or a boiler system, you know, there are a lot of different impacts as far as what season it is, how hard they're running their product lines, the cost of fuel, if they've expanded any lines since we did our initial audit. And so what we try to emphasize is that it's the starting emissions that we give is a snapshot from that particular moment when we were on site. Because there are times, you know, I did my initial walkthrough at this plant in the wintertime. And so they had a lot of their HVAC systems, their heating lines were running, you know, pretty heavy, but their chillers weren't running or were hardly running for their air conditioning. And so when we went back months later and the installation process started, we were seeing chill water valves that were sweating that weren't running when we were there on our first visit. So as far as tests and verification, we can use our infrared camera to take a before and after picture of before and after installation, and we can run both of those numbers through and see if it comes up to what 3E had told us it should be. It's like I said, it's not an exact science because of all the factors that come into play, but it's just a way to give the customer a pretty good idea of where they're at with their energy usage.
Okay, thanks, Jake. So the other question is a little bit connected to, I guess, the exact science there. Wondering what's the best way to calculate the energy loss due to moisture ingress caused by condensation on a chilled water pipe? Is that something that you do at all for your clients, Jake?
Not so much. We've done a little bit with condensation, but I know 3E does get more in depth into condensation and cold type piping. I think there's even some parts of it that'll tell you like the expansion of ice on like really cold lines. So I think 3E does dip into that quite a bit. I haven't had a whole lot of playing around with that part of the program yet, mainly just because our bread and butter is kind of looking for hot spots, the low hanging fruit or the fruit on the ground, which is typically going to be on steam systems or steam and condensate.
Okay. Next question is wondering, I guess I can reword this, does 3E offer any data on the longevity of the equipment that someone can pass on clients and stakeholders and kind of let them know?
As far as the life of the insulation system, is that?
Says, are there any data or tools available that you're aware of that measure the benefit of insulation with regard to equipment lifespan? So if you have insulation on the equipment, do we expect the equipment to last longer?
I don't know of any specific measures of time that 3E would provide. I know it's a talking point that we always try to bring up to our customers, just as an added bonus to fuel savings and emission reduction. It's just kind of a side note that we pass along. I would think that there are a lot of factors that go into play as far as their maintenance schedule, you know, what type of fuel they're using, how much time they're running their machinery. So I'm not aware of any, but I know that the savings exist for sure.
And I'd make a comment on that too, Jake. It does make sense though, that if it is running more efficiently, you would think it's going to last longer.
Sure.
Yeah.
Yeah, and
That's a great point.
And we definitely emphasize, you know, not just the longer lifespan for, say, a boiler system, but there's a lot of cost that goes into boiler water treatment, and there's a lot of savings to be had there too. And you could delve into that on a situational basis, and you could ask your customer, you know, what they spend on chemical treatment per year, and you could probably get close to some savings to where you could provide, you know, if you're using X amount of heat now and you cut that in half, and well, maybe you can cut your boiler treatment costs in half, and your boiler maintenance. So there's a lot of benefits beyond just the lifespan of the equipment.
Great. Final question before we wrap things up. Anthony was asking, what sort of future innovations do you see in this marketplace? We get that it's not sexy, as you said earlier, but where do we go from here? Will deltas get larger with new polymers and materials?
I don't know. If I was to answer that personally, I would think that something new that could be coming down the road that I believe needs to have happen is some kind of sensor technology that would actually say, yeah, the system's working or not. Because oftentimes if you see ice on your system, you know it's not insulating right. If you see a hot spot like Jake's picture right here, you know it's not operating correctly. So I think there's a place in the future around sensor technology that just as they have, I heard that they're putting sensors in roadways now that detect corrosion of the rebar. Those kinds of things I think are an innovation that I think could happen on the insulation industry. You got any comments around anything like that, Jake, on your?
Yeah, I know that there are some products out there that do exist. There's companies that do steam trap monitoring. A steam trap failure is probably a higher payback on fixing something like that than even insulation, because they're just dumping steam. Generally you're just trying to catch the condensate and pipe it back to your boiler. But if you have a steam trap that's not operating correctly, you're just dumping that steam back into your drain. So I know there's some steam trap monitoring. As far as other tech, I think the industry's come a long way from your picture of John Travolta that you had carrying the mud and the calcil block. There's a lot of options now for how to insulate things, especially items that maybe in the past were too complex and didn't make a whole lot of sense to insulate because of the time that it would take to cover it properly. There are some products out there that are more removable in nature, that can be custom made. I know a little bit about those types of products. I think that's a big shift that has happened in the last 10 years that seems to help our customers find more solutions instead of just being limited to one type of insulation. And then every time they have to break into the line, they've got to rip it all off and then have a guy come out and start from scratch. Now they have products out there that they can take the insulation off and then come back and put it right back on after they do their service. So as far as tech goes, that's the best I can do.
Okay, well, Jake and David, thank you so much for your insight today on insulation inspection.
Thank you.
Thank you for having us.
Awesome. You
Really
don't mind
appreciate it.
advancing the slide?
Well, I think I can do that. There you go.
Okay, so twice a year we have operations and maintenance training specifically for building engineers and facility managers. So this is your chance. Twice a year opportunity. It is at a reduced price this time, so no longer $950, it's $550, and that's a considerable savings for an 8-hour course. So feel free to log on to energymgmt.org and check a little bit more about this course and how you can learn energy management strategies for your facility. Thank you all today for hopping on for an hour to learn more about NIA and their installation inspections and 3+ software. Looking forward to the next webinar and have a great day, everyone. Bye all.
Thank you all.
Thanks.